Hi, here we have a demonstration of Yaskawa V1000 drives running with pulse input, and this Yaskawa V1000 drive is powered through a transformer because this one's a three-phase 200 volts input, and in Australia we have 415 volts three-phase input as the power supply. So it goes through a transformer which transforms from 415 volts to 210 volts. I'm not sure whether that's visible there, through some circuit breakers, and the pulse input is actually generated by a zinc chip. This one's a snickerdoodle board, which is based on a Zync 7000 SoC, and the pulse from there goes through LM338 339 IC, which is a comparator, and what it basically does is it increases voltage, translates the 3.3 CMOS output, low level CMOS output, to 10 volt output, pulse output, and the power supply for that comes out of the Yaskawa. And as you see, hooked it up to an oscilloscope, and if you have a look at it, you'll see that there's a voltage translation. The yellow waveform there is generated from the snickerdoodle, and the blue waveform is after the LM339 comparator has translated it up to 10 volts, as you see there. And as you can see, it's a 500 hertz waveform, and if I come back to the Yaskawa drive, we can have a look at the modified constants. So I've modified 3 parameters only here. So once the run reference source for frequency, that's set to pulse input, which is P101, is set to 4. Run source is set to digital operator, so I can run it from here, and the scaling is set to basically 1000 hertz, 999. So that's the maximum frequency. That's where you'll get the maximum frequency out of the drive. And if I go back, so that's the frequency reference. So the frequency reference is based on 60 hertz. That's the maximum frequency, and as you can see, because it's a 500 hertz wave pulse train input, it's half of 1000, and that's why you have approximately half of 60, which is 29.33. Now if I go down to, now if I pull the input to the comparator, you get basically 0 hertz because there's nothing generated after the comparator. So now the input to the comparator, I'm going to change it to double of the time, which means half the frequency. So that leads us to 243 hertz, which is 1/4 of the maximum frequency in the RP scaling, which was 1000. So 1/4 of 60 would be approximately 15, and that's what you see on the Yaskawa drive. And if I press run, so it's basically running at the same frequency. Stop. So went to 0 there. Run again. Okay, So now while it's running, if I change the input pulse train to double of that, it basically increases the output to 29.33, and again half of that. Yep, so 14.66, which goes to 15. And also what you can see is the input pulse train, which is U124, which is 244 Hertz, and that's close. 243 is what I'm getting. And if I double the frequency by changing the input to the comparator, you get 488 Hertz. Yep. And I press stop, so stop the Yaskawa drive. I have to get back. So that stopped. Now start again. And stop. That's it for now. Thank you.